let's get this started. Thank you all for joining. Hi, everyone. It's our 15th call, September 1st. Good to have you here. We have a good agenda. Welcome all back. As you know, we're having these calls on a monthly basis with the Graph Core devs. All of these calls are recorded and uploaded to our YouTube channel. So if you want to find it, you just need to Google the Graph Protocol, YouTube, and you'll see a dedicated channel there for core devs calls. And we also have a dedicated core devs workspace and ecosystem calendar that you can find if you follow this link you're seeing in my slides, the graph.foundation. The workspace will let you know the different working groups we have, the meeting notes, recordings. There's a Kanban board in some cases, and you can follow along with the latest updates. And there's plenty happening. So for today's call, we have an interesting agenda. We're going to go through the recently announced MIPs program that the foundation has put together. We've announced it last week. We will be hearing from GraphOps and the Networks Ops working group on Graphcast, the gossip network they've been working on. I believe there's also a GRC in the forum. We can post it in the show notes and in our chat, so you can take a look at it. And Dotan from the Guild will also share some updates on the few things we've added to GraphNode and GraphClient, which are pretty neat. I believe we're going to go over child filters and GraphClient, some support for live queries, GraphQL live queries, and then Bartosz from Figment. We're going to do. I'm sorry, I'm still letting people in. We're going to do a workshop, a quick workshop on what it means to build a subgraph for Tendermint-based chains. We've done something similar with Subgraph developers a couple of days ago, and I think it went fairly well, but might as well take the time and do it with other core devs and give the opportunity for other folks to ask questions. I think it went fairly well, so it's worth doing it again with a different audience. And lastly, Adam from Edge and Node, .NET APIs working group as well, an update on Substreams, also a fairly recent post we've shared, Adam has shared in the forum. I can also link it in the chat and show notes. Okay, so let's talk about MIPS. Quick overview, the whole point. So as you know, the Graph, we're pretty serious about decentralization. It's always been in our roadmap to have multiple networks supported multiple chains supported in our network. And you know that we are deprecating the hosted service, which is the centralized and free service that most Subgraph developers use and love. And this hosted service, when compared to our network, it supports more than 20 different chains, whereas on the decentralized network at the moment, we only have one, that's Ethereum mainnet, as most of you know. And this means like deprecating the hosted service means that it will go away in about 9 months from now, but not the support for all of these chains. And so there's a process in place we're working on. You can follow up in the forum. There's some interesting threads like the Epoch block or Oracle, where Adam has been updating on what it means to add support for a new chain on the network and what the process will look like. But now that we have MIPS, we can see there's a complementary program really where the foundation is incentivizing indexers to bootstrap all of these chains in a nice way. And by nice, I mean with nice quality of service. And so, yeah, bootstrapping indexer supply, making sure that we can serve these chains properly in a testnet environment first, and then moving on to our network or mainnet. Yeah, so you might have seen the incentives. We've allocated a total of 50 million GRT for indexers. That's 0.5% of the GRT supply, but also 25 million GRT for migration grants, just to make sure that we can migrate most subgraphs over the decentralized network and help out our community going fully decentralized. Quick breakdown, some information about the breakdown and the distribution of this GRT. So out of these 50 million, we're going to be allocating a specific amount for any given chain. And we're going to be announcing the specific allocation by midway through the program. That is, once we get support for the chain, we'll let you folks know how many GRT we are allocating to that chain. And by the end of the cycle, and you'll understand what these cycles are in a bit, by the end of each chain cycle, indexer will get access to 30% of that budget that we've allocated to that chain. The other 70 will be vesting, and participants will know more on how this whole thing will work out when it comes to vesting contracts. I'm just doing a quick overview now. So talking a little bit about this leaderboard, the way we're going to be distributing the rewards is based on a leaderboard. As I mentioned, we do want to make sure that we have a nice quality of service in these chains. And so we're going to be keeping track of a few things. Some things we can monitor on chain, like allocation efficiency. Some will be off chain, like if you're serving queries with low latency. We have like nice data freshness, not being too far behind blocks, for instance. So, and other metrics like providing support to other indexers participating in our forum, testing L2, and participating in workshops that is going to be held, that we're going to hold in indexer during future indexer office hours. So the higher you rank in this leaderboard, the more GRT you're entitled to, or you will be eligible for. As I mentioned, we're going to have different chains. We're going to be announcing new chains, or rather the future chain. Once we get a new chain supported in the program, we'll let you folks know with 2 weeks notice, so you can prepare your infrastructure, start syncing your archive nodes. And as mentioned, the GRT will be distributed after each cycle, and I'll show you a diagram next on what that means. The first chain is going to be Gnosis chain. We've just announced it, so we have some participants already syncing up their archive nodes. So a quick overview of what I was just mentioning. So the focus will really be on quality of service, monitoring stuff in the testnet. So as you know, we have Gurley, that's our testnet environment. We're going to be adding support for these chains there. Indexes will start serving subgraphs that we will be deploying there. We're going to be injecting traffic, starting with Gnosis. We're going to be monitoring QoS. And once the foundation and core devs agree that there's a good enough quality of service, that's when we'll be signaling that this chain should be now moved to mainnet. These participants will still be serving those subgraphs over mainnet. We're going to be monitoring just to make sure that they are still keeping up. And that's when the cycle ends. We'll, all the indexes will be scored based on all of these QoS and how they participate in the program. And by then we'll know how many GRT they should be eligible for. Once that cycle ends, we're going to repeat the same process. We're going to add a new chain, go in testnet, monitor QoS, go in mainnet, monitor QoS, repeat. As optional, if you participate in other things like testing our L2 bridge, the Arbitrum bridge, or even share feedback on new tooling that we are working on, such as Auto Agora and the allocation optimizer that I believe we've already covered here. That's gonna also give you some extra points. And so, yeah, hope that's clear. Let me know in the chat if you guys have questions, or as mentioned, we've had a whole workshop on, or an intro, and I've covered all of these as well during previous Indexer office hours. So if you want to know more, you can watch that recording. It's been uploaded to YouTube, and you can join future Indexer office hours to know more. And if you're not a participant yet, I highly encourage you to apply. You can still apply until the 15th of September. I will link I will add to the chat a link to our page when you can know more about the program, the different the different phases, and yeah, you can still apply, and we would be glad if you did so. Okay, that's it. I'm gonna stop sharing. We can talk about this or do some Q&A at the end, giving you the opportunity to ask questions. And so we can move on to the first topic in our agenda, that is Graphcast. And I believe, Petko, you can already share your screen and talk, right?
Yes. Thanks, Pedro. First, can everyone hear me okay?
Yes, we can.
Cool, awesome. Just a little heads up, my network has been a bit shabby, so if you lose me at any point or if I start cutting out, just say something and I'll reconnect. Cool, so let me share my screen, 1 second. Great. Okay, so now you should see my window with the presentation, right? With the Graphcast presentation.
Correct.
Just to be sure. Awesome, great. I'm gonna keep the chat open. Cool. So yeah, hello everyone. I'm Petko from GraphOps, and today I will be giving you a demonstration, or more like a high-level presentation on Graphcast, which is the Graphs Gossip Network. Initially, the headline was a gossip network for indexers, but seeing as that in the future this gossip network idea and Graphcast can be used to facilitate applications geared towards other network participants as well, like delegators or curators. That's why we think that the Graphs Gossip Network sounds a bit better. So I'm just going to give a quick overview on what Graphcast is. And by the way, I'm going to send in the chat the GRC because it has been published yesterday. So there you go. And what I'll be covering in the presentation is going to be more or less very similar to the GRC. So you can follow along or yeah, so let's start. Graphcast is meant to be a decentralized and distributed peer-to-peer communication tool. So something that is off-chain. It's not a part of the on-chain protocol operations. And what that communication tool can allow is basically at first for indexers to exchange messages with each other in real time. And those messages can be really anything. So information about their operations and anything else that's relevant. It is very important to note that this layer is completely optional, so you can add it to your existing indexer stack, or you cannot. And so the whole reasoning behind why Graphcast is needed, according to us, is because right now the only way for indexers to exchange information is on chain. So the network coordination happens on chain by submitting transactions, which obviously cost gas, and so it's not very efficient depending on the type of communication. So naturally, this situation makes it so that some messaging remains, some messaging is just in a way priced out because it's not maybe worth the gas cost. So this is what we hope to solve with Graphcast. And that's because the cost of exchanging P2P messages is near zero, which is ideal for coordinating without a concern for cost. Obviously, this Graphcast being off-chain comes with its own set of trade-offs. Like Graphcast cannot ultimately guarantee the truthfulness of the message, at least by default. We are going to work really hard to add things that guarantee that after basically the messages during the exchange of the messages. So but yeah, all of that is covered in the GRC. So again, I'm gonna try to keep this brief. So how will this actually work? So at first, we're going to develop a Graphcast SDK. So that's a software development kit that can be used to develop the so-called radios. So the radios are applications in the network, and the specific logic of the application of the radio can be pretty much whatever. So the Graphcast SDK allows the connection to the network, so connection to other participants in the network, and also provides a interface to interact with the network. But the radio is the place where all of the application logic happens. And when different participants run the same radio, basically that's when the communication happens. So I'm going to move on to the next slide, which is, the motivation. We talked a lot about that. So it unlocks basically new forms of communication among indexers that are not available today in this manner. Of course, as well, with that comes easier experience for ecosystem tooling developers. So the tools that indexers are going to be using, which are built on top of Graphcast in the form of radios, we're going to make it a lot easier to build those with the aforementioned Graphcast SDK. That whole thing will lead ultimately to the democratizing of the underlying data, because that way it's not like some team is building a application for indexers and they keep it on their backend servers and only they can leverage it. This is going to allow for a much more open environment for building these applications. Of course, as always, this as well comes with sets of trade-offs, but again, I'm not going to dive deeper into them here because I want to have some time for a live demo. So I've listed here some of the use cases that can be realized using Graphcast in the future. I'm not going to read all of them. You can just see them in the list. But of course, it's very important to note that the only limit to the future use cases of Graphcast is one's imagination, because essentially everything can be in the messages that are being exchanged, and the logic in the radios can be pretty much whatever. So anything that can be beneficial for indexers to share in a distributed and fast manner can be done. So now let's touch a bit about the tech stack. So we currently have a proof of concept that is using TypeScript entirely, and we are relying on the Waku protocol for the decentralized messaging features, functionality, basically. Of course, we are very open for discussion about alternatives. After all, we are building all of this. We are building all of this completely in the open. So we are more than happy to receive feedback, to participate in discussions on how this can get better and everything else like that. So the idea is that the TypeScript SDK abstracts over Waku, and it provides, first and foremost, it provides identity resolution, which is really important because that's what I said before, that the messages don't have any default truthfulness. This is at least a way to make sure that the sender is who they say they are. So this includes things like message signing, so that the indexer signs the message, and when another indexer, being a receiver, receives it, they can know where that message comes from, and they know that it is in that sense valid. As well as identity resolution, it exposes a rich interface for building the radios, because it kind of takes all of the great Waku messaging features and wraps them in a layer such that they are geared specifically towards the Graph protocol. And in this stage, indexers, but in the future, as I said, there can be applications on top of Graphcast that are suited for other roles as well. So as I said, we do have a proof of concept running, which is a POI cross-checker. So that's a proof of indexing cross-checker that I'm going to link as well in the chat. It's in our GitHub. So what it does, just very basically, it aggregates normalized POIs. So each indexer sends their POI for a given subgraph deployment on a given hash, and that way there is a real-time view of these POIs, and each POI attestation is backed by the on-chain stake of that indexer. So that way, when you want to ensure that your POI is valid, you compare it with the POI that is backed by the most aggregated stake. So and also it provides handling POI divergence by updating the cost model for the diverged subgraph deployment. And obviously this will be very useful once it hits a more stable version, because it will enable a very rapid detection of divergence. Cool. So just moving on to the just very quickly, next steps, obviously collect feedback from indexers as well as the wider community, like all of you today. Publish the Graphcast SDK as in the form of a library so that it can be used to develop radios, and as well further develop the Graphcast SDK and the POI cross-checker radio. So how much time do you have left, Hydro? Just want to fit the demo.
Yeah, you don't have a lot. You have we're already past the 25-minute mark, but how much time do you need? Like 5 minutes?
Oh, I can do it in 2 minutes.
2 minutes, perfect. Okay.
Yeah.
Okay, cool.
Cool, awesome. And yeah, thanks. This went a bit over what I was initially planning, but I just want to I think that the live demo is gonna show very neatly. Just 1 sec, because I want to share a different window. It's gonna show the workflow. 1 second. It's literally gonna be 2 minutes. Okay. Cool, there we go. So this is the terminal where I'm just gonna run the proof of concept. Of course, building is gonna take a bit more than. No, you know what? Yeah, my network is being shabby. Sorry. I will be sharing a record. I will be sharing a recording of the proof of concept, and I will share it as fast as I can on the Discord, so you guys can check that out as well. I hope that makes sense. Thank you all, and that's it for me.
Sounds good. Thanks, Petko. Yeah. I didn't mention before, but we're going to have some Q&A at the end. I just want to make sure that we can go through every agenda item. And at the end of all of these presentations, let's say you folks can just react, raise your hand. I will allow you to speak, and you can ask your questions away. Okay. All right. So moving on. Dotan, Graph Node and Graph Client. Feel free to. There you go.
Sure. Hi, everyone. I'm Dotan. I'm the CTO of the Guild. We're working on the entire GraphQL layer, both in GraphNode and in Graph Client, which is the actual query layer and the client for the graph. Today, I want to do a quick demo. I know that we're kind of short in time for 2 new features that we recently added. So we'll start with the Graph Client. Recently in Graph Client, we added a built-in support for live queries. So live queries is a concept in GraphQL. It's also in RFC level for the actual GraphQL spec. The idea is that every query can be a live query. So that means that you can take a query and just annotate it with the live query. And it doesn't really matter what kind of implementation we have under the hood. The idea is that we can make the query live. So by leveraging really cool transports like SSE and things like that, we're able to do a lot of cool stuff on the GraphQL layer. Specifically in Graph Client, in the latest version, live is already built in. And under the hood, the implementation that we have at the moment is based on polling. But the general idea of having live queries is not only to poll and fetch latest data. It also means that you declaratively say that a query is live, and it means that you get live updates and it's being updated. By doing that on the Graph Client layer, we're basically decoupling the GraphQL client that you might use. Maybe it's Apollo client, Urker, Relay, doesn't really matter. So some features are no longer depends on the GraphQL client that you're using, and they're part of the execution layer and the network layer, which is Graph Client. So if you're using Graph Client, you can specify the live directive. I'll just run it in background just to see here the data. I just have like a subgraph here. It's on the hosted service just for this demo. I'm fetching transactions and I just asked for the first 5. What happens under the hood is that we're doing polling and this is automatically updating. So if you have GraphQL or GraphQL clients that already supports live queries, which is most of the GraphQL clients today, you'll get that out of the box. So instead of getting just a single response, you'll get a stream of responses when data changes. So in terms of the point of view of a dApp developer or a front-end developer, you don't really need to do anything. You just specify live, and behind the scenes, you'll get all the data being updated, cache updates, and so on, also supported. It's a bit different than polling, because polling might say that you want to get the latest state. With live, we can do more stuff, like getting a list of items and then update it. But this is just like an initial step, because later we can do things like stream and defer, which are also new concepts in GraphQL that might get into the spec at some point. So with things like live and defer in the future, we'll be able to just ask for partial data, or only the first n amount of records in an array. And this is something that is decided completely by the client. So we can do crazy stuff with GraphQL in the future. So live is just one step. So yeah, I don't know if you got that. Yeah, but this subgraph is updating frequently. So I'm getting all the transactions here. So I always have the latest state of the first 5. So this is really cool, and it's updating very frequently. So that's all with live. If you're using Graph Client, you can already use it right now with the latest version. Besides for live queries, we also have a really cool list of features in Graph Client. You can do composition for multiple subgraphs. You can customize the fetch strategies, use fallback for the hosted service if you're migrating to the decentralized network. So you can do a lot of stuff with Graph Client. So if you haven't tried it yet, go ahead and try it. You can use it in any front-end application with any, it's JavaScript basically, and you can integrate it with any GraphQL client that you might already use. It just acts as an execution layer that gives you an enriched GraphQL experience. So all of these are supported and a lot of cool stuff. So yeah, just give it a try, and feedback is always welcome. Yeah, so that's all with live. The second demo that I wanted to do today is for the nested filters. So nested filters, I think this was the most requested feature for GraphNode in terms of the GraphQL layer. So this is just landed recently, like a month ago. And I'm going to show here a cool example of how am I querying partial set of the data based on complex filters. So let's say here we have the live peer subgraph, and I'm querying it for the pools entity. So let's say that I'm getting all the data here. I know that before we already had the where filter that gives us the option to filter for some parts of the data. But now for every linked entity that we have within this entity, we're able to add more advanced filtering. So what does it actually mean? We can filter the pools based on the round entity and based on the value of the initialized field. So let's see an example here. The query that I have here is basically filtering the pools based on the initialized field. So if I'll query it, you'll see that I'm only getting the pools entities that has the initialized value set to true. If I'll go to a bit more to the extreme, I can also do stuff like, let's say I want to get all the pools that are linked into a round of a specific value. I don't know, let's take this one, for example. Yeah, I can just do here, ID, as per specific ID. Yep, and now that's all the data that I'm getting. And the ability to filter the root entity based on some nested fields basically means that we no longer need to fetch tons of data, filter it on our end, and then decide what to do with it. We can just query the graph directly for the data that we actually need. So this will probably reduce cost and will probably make things a lot simpler for everyone who consume data from the graph. So yeah, this is already live and live. So feel free to try it. Yeah, just like with Graph Client, any feedback is always welcome. Yeah, I try to keep it short. So if you have any questions, feel free to ask in chat or open an issue on GitHub.
Thanks, Dotan. Right on time. We're only 2 minutes late, which is good. Okay, cool. Moving on. Bartosz, are you taking lead on Subgraphs for Tendermint-based chains? Cool.
Yeah, exactly. So hello, everyone. I'm Bartosz, and our team at Figment, we've been working on the Cosmos integration, which basically brings the graph into the Cosmos ecosystem, which I think opens up like a lot of opportunities. So let me briefly, really briefly talk about this integration, and then I'll walk you through the whole process of creating a subgraph, building and compiling, deploying, and so on. So first of all, like the most important thing about this integration is that it uses the Firehose framework developed by Stringfast. And by that, it gets all of the great features like Substreams built in. So that's one thing. Second, the way we implemented it, we've done it on a Tendermint level, on the level of the Tendermint library. So as you may know, the Tendermint library is basically a consensus mechanism used for all of the different chains in the Cosmos ecosystem, which means that by doing that, there's actually only one integration that allows us to integrate pretty much all of the different chains that exist in this ecosystem. So there's one Firehose that we need. There's one graph node integration. And the only required step to bring in like a new chain is instrumenting the binary, like the nodes binary. And so far we've done it for Cosmos Hub, for Osmosis, and Juno is in the works too. But actually we've seen community building their own, like the integrations by themselves, which I think is really awesome. So yeah, let me move on to the example. All right, so here's, by the way, here's like, I have a local Firehose setup, which is running a Cosmos Hub node, which is connected to, and then I have like a graph node also running locally, which basically is connected to that Firehose. So I'll show you one of the example subgraphs that we created specifically for Cosmos. And by that, I'll probably demonstrate like what are the key differences between like Ethereum subgraphs and Cosmos subgraphs. So it will be this one. I have it already here. Not this one, this one. Okay, so let's see the manifest first. So here's the subgraph manifest, and you can actually compare it to the Ethereum one. This is the gravity example. So oh yeah, okay. So yes, as you see, like first of all, there's different kind of data source here. In Ethereum subgraphs, we have this Ethereum contract kind, which is actually important because in case of the Cosmos integration, there's actually one data source per each subgraph because Cosmos chains are pretty much like smart contracts on Ethereum. So this is like the key difference between those two ecosystems. So we can think of a chain in the Cosmos ecosystem as a smart contract on Ethereum, like maybe with the exception of Juno, but that's one of the exceptions. So there will be, most cases, there will be just one data source for a subgraph, and it will be just like the network data source. So as you see, it's Cosmos kind. Also, the network is specifying the Cosmos hub here. And the other difference that is important are the handlers. So in Ethereum, there are 3 handlers: block handler, block handler, event handler, and call handler, I think. But in the Cosmos integration, they're actually also 3, but different ones. So we have a block handler, which is pretty much the same. It gives you all of the data related to one block. There's the event handler, which is a bit different, and I'll talk about it in a second. And there's a transaction handler, which actually comes with all of the data for all the transactions. So it contains all the data that you can pull from the chain. So let's go to the example, and let's see the mapping. So as you see, it's pretty similar. Like the example I have here is basically indexing all of the validator rewards in a very simple way. So it's mostly to demonstrate how it works. It's not like a real use case, but yeah, it's just an example subgraph. So it takes like event data. So this is where it gets different from Ethereum, because event data in Tendermint and all like Tendermint based chains is basically a list of attributes which have keys and values which are both strings. So this is like the data that we get from when we use the event handler. So as you see, I get the event data. I'm actually interested in the reward event only, which is specified here. Like this is the event type that I'm interested in, and in the mapping, actually pulling the data here and reading the attributes, which is the amount and validator, and then just store it in the database in the subgraph. So that's pretty much it. Now I think we can compile it. So it's the usual, like the flow is very similar, almost identical to the one that you have for Ethereum. So it's first like generating the code, building the subgraph, and now we can first like create it locally in our local instance, and then we can just deploy it. Yeah, so as you see, like it's already started indexing in this local instance, and if we open up the this thing, we can actually query it. So I have a really simple query here defined, which basically pulls like one address. So the rewards for one validator, and it's actually returning all the data. So yeah, so this is how the event handler looks like. If we have a bit more time, I can demonstrate the other type. I don't know, Pedro.
If we have, I think we have 2 minutes, Bartosz, if you
okay, perfect.
You can fit in.
Yeah. Sure, yeah. So I'll show just another example. So I said about event handler, but there's also a transaction handler, which gives you all of the data. The one caveat though is that here you need to decode the data on the subgraph side. This is like the major difference from Ethereum, where you get all of the data up front. So decode it up front. So let's see actually how it looks. So the definitions here in the manifest files pretty similar, pretty easy. So it's just like specifying it's a transaction handler, which basically triggers on every transaction. So there's like one handler function, handler method for the whole subgraph. And here's how the mapping looks like. So we have the handler function. It receives the transaction data, which then needs to like the data that we get, and specifically the messages. So messages are kind of like there are multiple messages in each Cosmos Cosmos transaction. So this is how like decoding on the subgraph side looks like. For this, we use a library called ASProto. It basically generates the bindings, like protocol bindings for assembly script. and it's actually like the coding boilerplate that we already like generated beforehand. It's actually here. So yeah, and it's basically imported in this file and used to decode the, in this case, it's like a delegation message, which is then later on just stored like just in the previous example. So yeah, so this is how it looks like. There's actually one more thing. So the whole like decoding part is on the Subgraph developer end, but to make the Subgraph developers' lives easier, we actually created a library which comes like with all of those bindings, like protocol bindings out of the box. So once you like, this is the only thing that you need to really interact with this chain, basically to decode the messages, all of the messages for that particular chain. In this case, it's just Cosmos Hub network. So yeah, so I think that's all. Yeah, thank you.
Perfect. Thanks, Bartosz. I'm glad you did decide to walk us through this last bit. I think it's important for folks that are mostly used to build subgraphs for EVM based chains and smart contracts, and then you get the whole data model and you know how to work with it. I think this one is fairly different, but I hope that's clear now. So yeah, thanks.
Yeah, thanks.
Thank you. Okay, Adam, you ready? I don't see Adam.
Hey, how's it
going? Oh, there you go.
Sure, let's share some slides. Yes, this is very much a, I guess, work in motion. I guess where a bunch of the other stuff is excellent work already done. We thought it'd be good to run through Substreams. Obviously, we've been talking about these across the ecosystem for a while. We're kind of in the and now I guess into the fun bit of building on top of the original implementation. StreamFast have been making great progress, leading the charge there. And I guess what we're going to be focusing on today is more the current collaboration between StreamFast and EdgeNode, where we're working on essentially taking substreams and streaming them into GraphNode. So essentially, your substreams process can make its way into a sort of an auto-generated subgraph API. So hopefully this can be quite discursive, but we'll see how that goes. I think the in terms of overall status, so teams internally and externally are experimenting with substreams, which is really cool to see. Across a bunch of networks, one of the beauties of substreams is that if you've got a fire hose, and now we've got fire hoses across obviously EVM chains, near Cosmos, Solana. If you have a fire hose, you can run substreams, which is a really cool unlock for all of those ecosystems. And we're seeing experimentation across the piece. In draft, we're starting to see some of the limitations or hurdles that that teams are hitting up against. So one example within EVM specifically is essentially just having to write a lot of boilerplate code when extracting, say, events, which is sort of done or can be streamlined via sort of code gen from the sort of a smart contract ABI. So those kind of helpers, those kind of learnings are coming up, and it's cool to see. I think Matt Vachon, who's not on the call, jumped on that and has a draft PR, which should hopefully just make it much easier to go from 0 to sort of working substream without writing so much boilerplate. And there's actually really good documentation at substreams.streamfast.io. Don't know what the ampersand is doing there. But that's a great place if you want to sort of get started, and I guess there are more notes on that at the end. So that's Substreams core stuff. Substreams and Subgraphs published the GIP for this on the forum earlier this week. At the outset, this is a really simple implementation in GraphNode, which essentially imports the Substreams package in the manifest. So it's a new manifest format versus the formats which I guess most subgraph developers will be familiar with. Essentially imports a Substreams package and persists the data from substream into Postgres, and it's then queryable via the usual Subgraph API. So that's, yeah, as I mentioned, been a sort of collaborative effort between teams. Felipe is more than this from Edgenode with Eduard and Julien from Streamfast. And so the point that we're currently at is that we've got the sort of a working example end to end, which is really cool to see. There's some rough bits around the edges which we're ironing out, but essentially we're at the point where we want to start to push that proof of concept a little more, and I guess just wanted to raise a couple of the discussion points which came up in yesterday's sort of working group call. So I know a couple of people are on the call, so I think Felipe is, and I think Edouard and Charles from Streamfast are there too, so do feel free to jump in, but just wanted to raise some of the things that we're discussing. So firstly, validating the initial graph node integration. I think there's the initial step, which is going from, and Felipe can correct me here, but I think it's kind of a pretty simple block handler that we've been using for the initial testing, to essentially importing and seeing how more complex substreams perform. So obviously AMMs, so your Uniswap type sort of dexes are really applicable to substreams because there's a lot of data, and subgraphs have often struggled to process them as performantly, and that was one of the driving things behind substreams. So I think that's one of the places we're going to start going beyond the initial Hello World example. I guess then the next sort of like as well as just making sure that things work, there's a sort of ensuring correctness during live operation. I think that's everything from seeing how the whole system handles when the whole system reacts when one or both components restarts or loses connectivity, making sure that the whole thing works and recovers gracefully, and sort of as is expected. So I think things that we've seen, I guess, over the months and years is just making sure that failures work as expected, that when you lose a connection, maybe when you're partway through indexing a block, that you sort of start in the right place, and those sort of detailed things are often things that really important to get right at the early stages. So those sort of correctness things during operation will be key consideration. Testing determinism. So I think this is obviously something that's really important, but essentially the simple fact that a substream being imported into a subgraph should essentially have the same outcome whoever's running it, and it should have the same outcome every single time. So we'll want to do some sort of testing there, and yeah, those things I mentioned before around handling failures and restarts and those kind of things will need to be part of that testing. Performance, but I think then one other consideration is obviously always checking versus the chain and checking versus what you see in a sort of equivalent subgraph will be interesting benchmarks for us. And then once I guess we have that confidence in the sort of correctness and determinism, getting into performance benchmarking and scalability benchmarking. So that's how does the whole setup perform when you've got hundreds of substream powered subgraphs being indexed by one graph node. How does it work when you have a particularly heavy substream connecting to the substream server? Does it perform as expected? So I think that there's a bunch of local and sort of simple testing that we'll do before I guess we move to testing in a more sort of hosted environment. Is there anything I guess I've missed from the people on the line as we're sort of thinking about validating the initial integration?
Nope, I think you're good.
Cool.
Thanks, Adam.
So then I think one interesting discussion that's kind of come up is the sort of tooling to build and deploy. So see with substreams, your folks will be developing substreams in Rust using a sort of Rust tool chain, but obviously the familiar means of deploying a subgraph is with GraphCLI, which is obviously in JavaScript and so is NPM, and I think we need to work through what that looks like, because this is something that we I think discussed yesterday, where I think the working assumption was that was that developers would expect to be able to deploy these sort of substream powered subgraphs with Graph CLI. And so we need to update Graph CLI to support substreams. But I think then a counterpoint which Felipe made, which I thought was really interesting, was really interesting, was that if substream developers are like working in the sort of substreams context and they want to deploy, they won't necessarily want to import this sort of npm package. It might be a whole different workflow that they use for deploying subgraphs normally. So this is a proposal that actually you could take, I guess, a more Rust native approach via a sort of cargo plugin. And so I think it's an interesting point which I think we need to kind of work through what is simpler or makes sense from a sort of substream and subgraph developer perspective. Yeah, Felipe, I don't know, because I know we discussed this yesterday. I don't know if your thinking has sort of evolved, but on this tool.
No, I think an interesting thing that we could discuss is starting to slowly move some parts into Rust and then just create some bindings on Graph CLI, and so reuse, so we don't have the choice of one or the other, but instead it's kind of consider an option where we do the work and reuse it on Graph CLI. But yeah, I think you basically mentioned everything else.
Yeah, if Vincent's still there, I think you were pretty open to, I guess, the Rust-based approach from a sort of developer perspective. Maybe he's there. We lost him.
Oh, Vincent, you can talk now.
Oh, yeah, sorry, I wasn't able to speak. I might be missing some context on this one, but I'm setting up a call with Matt afterwards or next week to talk more. So far, I'm open to either options.
Makes sense. Cool. So then, I think on a related note, I think there was an interesting discussion yesterday about, I'm conscious of time, about sort of schema and graph out definition. So this is essentially, there's one slightly gnarly piece between substream and subgraphs where the sort of substream based sort of protobuf definition needs to then map to the sort of GraphQL schema that's used by GraphNode. And so obviously we don't want that to necessarily in the long term require sort of manual typing by developers and mapping. And ideally we have tooling that helps there, but I think there's an interesting question as to whether you sort of start with the schema and that then informs your sort of substreams graph out definitions, or the other way around, and your graph out sort of has an auto-generated GraphQL schema. I think the direction travel is that starting with the schema is maybe makes a bit more sense. But I think this will be an interesting area of discussion that may be informed by some of the toolchain stuff we just mentioned. And then very quickly, yeah, I think that's maybe, I think there's one missing. There's a slide which I was expecting, which isn't there, but that was more about, there are some interesting challenges around productionizing the substream server, which again comes back to some of the testing we were talking about of like how to handle scale, how to handle load, how to degrade gracefully. And so those are the sorts of things that we'll only sort of start to see as we start to test more and more subgraphs and substreams. So I think in interest of time, I think we're just at time now, Pedro, but getting involved, try Substreams out, substreams.stringfast.io, review the GIP on the forum, and get in touch if you're trying out Substreams, if you're hitting hurdles. I think in the Discord, there's a Substreams channel. And yeah, engaging on the forums also strongly encouraged. So, or on GitHub as well. So lots of channels, maybe that's more confusing. But we're excited that so many people are giving it a go. And yeah, we're looking forward to getting this out in the world.
Very cool. Yep. And we are at time, but I want to give folks the opportunity to raise their hand and ask questions if they want, assuming that some of you may stay for a couple more minutes. There you go, Matthew. Oliver. Okay, let's start with
Oh.
Matthew. You, yeah.
Sure, thanks. Just a quick question to Petko. I'm just wondering, what's the roadmap looking for you for the next steps for Graphcast? And yeah, how do you see this evolving?
Thanks, Matthew. That's actually a great question. The next steps are basically pretty much finishing up the proof of concept, which is now on GitHub. After the proof of concept, we are looking to develop a MVP that actually network participants will be able to use and to give real feedback, because right now the proof of concept isn't really usable. So that is expected to happen sometime within the next month at max. So we'll definitely have a announcement when the proof of concept is stabilized, is sort of moved to a more MVP stage, and yeah, then it will be usable by indexers. So that's like the short-term roadmap. And then once we get some actual feedback on the MVP, we're going to develop a much more formal sort of doc on the roadmap after the MVP. I hope that answers your question.
Yeah, absolutely. Awesome stuff.
Matthew, Oliver, you can speak now.
Hey guys. Also a question for Petko here, with regards to the gossip network. Do you see, and if so, how would you assess potential regulatory concerns that a gossip network could facilitate collusion amongst indexers, such as price fixing?
That is another amazing question, Oliver. Thanks a lot for it. Unfortunately, that is way too big of a topic to unwrap here, and specifically about the price fixing, because I know it's a very interesting topic. And I just want to say that ultimately, the gossip network won't stop people from doing that, but we will do our best with the help of the wider community, of course, to kind of, well, not enforce, but add some guarantees and some rules, and ultimately a reputational system that kind of makes sure that everything is as fair as it could be in this context. But again, yeah, that's a great question, and we might actually write a blog post or something on the topic, because it really is huge.
Okay, thanks again. Great question, Oliver. Thanks for sharing. And I see Edward is also sharing a link to Substreams docs. That's substreams.streamingfast.io. I believe Adam also mentioned it. And I don't see anyone raising hands anymore. If we don't have any more questions, no, I don't think we have. Okay, so we should wrap it up here. Again, thank you all for joining. This will be uploaded to YouTube. And yeah, I'll see you soon. Thank you so much.